Yeah, the other thing that we may be able to do is that you just demo something on your computer. Um, but anyway, let me get started with the lecture and I'll think about it. All right. So this is the last part of this rather long chapter, where the purpose is to get to a bunch of intricacies in Java. Can I talk? So, so one of the more mysterious aspects of Java for many programmers is what's called generic types. Now, you've seen generic types like all your life, starting with ArrayList and 46A. An ArrayList is, as you know, a container for whatever, and the whatever is indicated with the angle brackets. So you've used an ArrayList of string, an ArrayList of icon or whatever, and it's not really that hard to use, right? They just tell you to put the type into angle brackets, and then off you go. Well, of course, someone had to write an array list, and the way to define it is actually also relatively simple. So we start out saying we want an array list, and then afterwards you put in brackets and then some type parameter. In this case, uppercase E for element type. It's customary to use very short letters for these things because they're supposed to be generic. You could say element type or something, but that's not what people do. They just use something short, E or T or U or something. So that type variable is used in the declaration of the generic type. Over here, the get method returns a value of type E, whatever E may be. And that's just how we want it, right? You have an array list of strings, you call get on it, you want a string. You have an array list of watermelons, you call get on it, and you get a watermelon. So that's where the type variable comes in. The same thing, let's look at the set method. So it takes a new value of type E, and it returns something of type E. What does set return? Set, what does it return? So I heard E. Well, that's the type of what it returns, right? But what does it actually return? So I heard the new value. It's actually not the new value. It's the old value. So trivia fact of the day, set gives you the old value just because it can. Right? Obviously, it can read the old value, and then it gives it to you just in case you wanted to know. I don't think that I've ever used it, but it's a cheap trick. So in the private part, we see the E as well, because of course what an array list does is it keeps the elements in an array, and here we're saying it's an array of elements of type E. All right, so I'll come to this note in a minute. Okay, I'll say it, but we'll get to it in great detail. So let's say we have a subtype relationship. We have a manager is a subtype of employee, and now we have an array list of manager. And so in the slide it says that's not a subtype of array list of employee. In other words, array lists don't do what arrays do. With arrays, we said subtypes are preserved by arrays, but for array lists, that's not true. And we'll talk about that in excruciating detail in a couple of slides. So, in addition to generic classes, we have generic methods. So here I have a utils class. It is not a generic class. You can see that because there's no brackets behind it. But here I have a method that's a generic method. It takes a type parameter here that's put in after the modifier is public static and before the return type. So there's not just one fill method. There is an infinite family of fill methods, one for each type E. So the fill method takes an array list of type E, a value of type E, and a count, and then you can see it adds that many values, and that's many times the value to the array list. So it looks like a potentially useful method, right? Just adds count copies of this value to the tail of this array list. No, why not? You can see it's a generic method because it operates on array lists of arbitrary type, and you can see how the type parameter here appears both here and here. It's the same parameter to indicate that when we have an array list of strings, say, we want to have a string here. If we have an array list of icons here, then we would want to have an icon here, and so on. So it's a generic method. Generic methods are a little bit easier to use than generic classes, in fact, because when you call it, as I'm doing it here, it's a static method, so I call utils.fill, and then I just specify the parameters. So I have here my array list. Here I have the thing for the value here, and then I have the count here. And notice that in this call here, nowhere did I have to specify angle bracket string. Instead, the compiler inferred angle bracket string, because angle bracket string was the only thing that would make it work. This thing here, what that was passed here, was an array list of string. This thing here was a string. And then out of those two facts, the compiler discovers the fact that E must have meant string. So that's it. So if you declare one of these, you still have to say you want to have an array list of string, but when you use a generic method, then the compiler will do the type inference. So that's generics 101. So now we're getting a little bit more advanced. We're going to talk about type bounds. So I'm going to start with this method here. This is an append method. It takes two array lists. One of type E, another array list of type E, and then it appends the second one to the first one. Sounds like a potentially useful method. And it works for array lists of any type. I can take an array list of strings and another array list of strings, and I can do the appending thing. But it's not as flexible as I would like it to be. Consider the case that I have a given array list of shapes, which could be arbitrary shapes, rectangles, ellipses, polygons, whatever. And now I happen to have an array list of rectangles. I don't want to append them all. That sounds like it should be possible. But it is not without us doing some heavy lifting. Because right now, if you try to call append of the shapes, rectangles, the compiler is going to say, I can't make this work. I cannot find a single E that is both a rectangle and a shape. So instead, you have to use bounds. And so here is one way of doing it. You can say, fine, I'll give the array lists two different types. This one is an array list of E, this one is an array list of F. And now I need to specify what is the relationship between E and F. Because, of course, you can't have an array list of strings and an array list of watermelons and hope to append the latter to the former. That would not be type correct. But as long as F is a subtype of E, then it's fine. You can take, say, an array of employees and append to it at the end an array list of managers. They're all employees, so that'll be fine. So the way that's described here, sorry, there's a space missing here. You say F extends E. So F is a type variable, and there's a bound here that says it's constrained by the fact that F must be a subtype of E. So they use the word extends here because it's a reserved word, they had it available. So extends really means extends or implements. You can have more than one bound, well, that's pretty rare. You could say something like E extends one in this case, interface type, and then the other ones you join them up by the end. We won't see that, I think, but it's legal. So now we come to another refinement that's very common in Java. In fact, that's more common than what you've seen so far. If you looked at the previous slide, you'll notice that the F that we have in here, it was really never used. It was used once to say that B is an array list of this type F. So there's a convenient shortcut for that, the so-called wildcards. So with the wildcards, you can drop the F and instead just call it question mark. And then when you use it, you have to say, well, it's not any type, it's a type that extends E. So when you look at this, it says what append does is it takes an array list of E's to that array list, it'll append another array list of any type, provided that it extends E, which I think is reasonably easy enough to read, right? So for some type, there's a subtype of E. So by in the simple form, wildcards really are not tremendously mind-bending. You simply say, I want to have some flexibility in this type, and you express what that flexibility is. So how does it work? So let's have a look at some of the methods. So we have this array list question mark extends E. It's some kind of a type. It's a wildcard type. What methods does it have? Well, it has methods get and set and so on. So over here, let me go back here. Over here, what we were calling a method, see, B is the thing that has the wildcard type, right? B is an array list extends question mark. Over here, we were calling B.get, and it obviously worked just fine. So let's see here. What is the return type of B.get of I? While you ponder that, let me see if I can't get myself a tool thing here. Okay. So I called B.get of I, where B was an array list of question mark extends E. So my question is, what is the type of this thing? What's that? Yeah, the type is question mark extends E. And I put it in quotes because you can't actually write such a type in Java. The compiler can infer it. So you couldn't declare a variable of type question mark extends E. But that's kind of the type. So this thing is of some type. We don't quite know what that type is, but we know that type extends E. So then when we go on further by saying A.set, or what is A.add, right? A.add, that stuff here. Then the compiler says, let's look at this add method. It requires a value of type E. What we're giving it is a value of some type, whatever that may be, that extends E, so that's fine. We don't have to know exactly what that type is, but it's perfectly fine. Now when you look at the other way around, let's look at the set method. The set method has return type question mark extends E, and it has parameter type question mark extends E. And now the weird thing about this method is it's impossible to call it. Almost impossible. So let's say that we're giving this method here an element of type E. Then the compiler is going to say, well, that's not good enough because this thing wants to have a value of type, some type extending E, but I don't even know what that type is that it wants. And therefore, it won't compile. So no matter what type you give it, it's going to say, well, I don't really know what that type is. So you cannot call this method. You cannot feed anything in there with one exception. No, even if you give it something of exactly type E, the The compiler says that can't be right because it wants something of some specific type that only this method knows, but I don't know. And so that's not known. But there's one value that you can put in. So if you had that would not work at all. If you had something where you say object Fred equals whatever, then it would say, well, object is not a subtype of E, right? Unless E happens to be object. No, that's right. So you can give it null and it'll happily take null. Every other value, it's not going to work. So for all intents and purposes, when you have a collection and you give it this wildcards type here, what you're saying is, I'm only going to read from B. So that's a very good way of thinking about it. So in this case, it means that any methods that try to put something into B here aren't going to work because there's no way to invoke them. And that makes perfect sense here because we're mutating A, but we're not mutating B. And so what the wildcards give us, if you remember with arrays and the array store exception, the array store exception was not actually all that nice. It means that there are mistakes that can happen at runtime that are undetectable at compile time that make your program potentially die with an exception. So here we have a perfectly safe way of saying, I want my wildcards right. Here we have a perfectly safe way of saying that I only want someone to read from this collection, and that's what the wildcard is. In this case, a good. Now, when the bounds can go in one direction, they can also go in the opposite direction. So you could equally well have written this method by, instead of using E and a wildcard in the first slot, you can use just the F. If you remember from a few slides ago, we had both E and F. And then you can use the F here. But then you have to use a different kind of wildcard in the first one here. And so this is a superclass bound. So in this case, we're saying, okay, we're going to append this thing, which is of type F, to another list that is of type, well, it could be of type F, that would work. Or it could be any supertype of F. If, for example, this thing here was an array list of object is a supertype of every other type, that would be fine. If this thing was an array list of managers, and this was an array list of employees, that would be fine. Employee is a supertype of object. But if this was an array list of executives, then it would not work. You can't put mere managers to the end of an executive. So the super works just as well. And so in this case here, let's look at this add method again. So this add method has type $super F. So it is some element of a type that we don't really know what it is, but we know it's a super type of F. Now what are we putting in here? We're putting this thing in here. So if you look at b.getI, we know what type that is. What type is it? Yeah, F, right? Because B is of type array list of F, we know it will get, it's of type F. So this thing is of type F. Now, this thing here has a parameter of some type that's a super type of F. It might be object or employee or something. And that's fine, because we don't need to know what that type is. We can still pass something into there as long as it's of type F or a subtype of F. So this will work. In other words, the A here now has become capable of being written to. Whereas previously, when we did it on the other side, we weren't able to write to B. Conversely now, if you try to read from A, you're not going to get much useful stuff out of it. Because if you now call A.get, you don't know what type it is. All you can do with it is put it into an object. That's the only type that you can safely use. So in other words, when you have something with a super, then this is a data structure where you can put stuff in. If you have the extends, then that's something where you can get something up. So here. So there is there's a nice saying that to describe this, and it's called producer extends. I should put that on the slide, and it will. And consumer super, and it's called the Peck's rule because producer extends. Consumer super. So a producer is something that gives me stuff. So the array list from which I read was a producer. It produced new values. Then in the other way around, where I sent them to that thing declared was a super, then the first array list then consumed elements. All right, so that's wildcards in a nutshell. And it doesn't seem super confusing. We went through this. But let's look at an example where it gets a little bit more involved. So what do I have over here? I have a method called getMax, some static utility method. It takes an array list of e's, and we compute the maximum in the usual way. We get the initial element, then each time we check with comparator whether we get something that's larger than the max, and if so, we remember the larger one. So let's look at this carefully. A.get of I has type, what type? Yeah, let's see, array list bracket E is A, so that means the element type is E, and this thing has type E. So we have something of type E, and we're calling compare_to on it. How do we know it's comparable? Because it says so, right? Over here, we put a bound and said that E must extend comparable. If we omitted that, the compiler would refuse to compile this because it says, I don't know anything about the type E. I don't know if it has a comparative method. But by saying it extends comparable, now the compiler knows it has a comparative method, and it's all fine. All right, so here's the comparative method, and this is all perfectly good, right? Oh, notice, by the way, there's a bit of a subtlety. Comparable is itself a generic type. So we can't just say comparable, we have to say comparable of what? Well, so let's say this was an array list of strings, then this would be string, and string extends comparable of string, because the comparable type is the one that's used in the comparative method. So, this looks perfectly fine, except it fails with fairly realistic situations. For example, let me make this, I'll use this example, and then you do the other one in the lab. So, let's say I have, for whatever reason, an array list of Gregorian calendars. So these are date objects from a somewhat old-fashioned date. Then I try to get the largest dating. Now, Gregorian calendar is comparable, so it seems like it should work. But the compiler is going to say, I'm not going to do this. And here is why. The compiler says, if I have an array list of Gregorian calendar, then E must be Gregorian calendar. So, does Gregorian calendar extend comparable of Gregorian calendar? Let's find out. And so, when you look at it here, you will see that Gregorian calendar as it's serializable, clonable, and it implements comparable of calendar. What the heck is calendar? Calendar is a super class of Gregorian calendar. And so why does it implement comparable of calendar? Because calendar already wrong one. Calendar already implements comparable of calendar. And now we're in a weird situation. Let's draw this UML diagram so you can see that what our problem is. So here we have Gregorian calendar. It's a subclass of calendar which implements comparable of calendar. Now, if we could just make it so that we make Gregorian calendar implement comparable of Gregorian calendar, then we would be happy. Then we would be able to use it in the example that we just had. But unfortunately, that is not possible. And it's not possible for an unintuitive reason. And that is that the way that generic classes work is that they only exist in the compiler. The virtual machine knows nothing about generic classes. In the virtual machine, all types are erased. For example, if you have an array list of strings and you have an array list of watermelon, in the virtual machine, they're all plain array lists, just array list of objects. So every type gets erased for object in the virtual machine. And that's a historical thing, that when generics were only added a number of years after the virtual machine was first created, and they did not want to mess with the virtual machine at that point. So they came up with this trick of type eraser, which means that they didn't have to rethink the whole virtual machine. And that sounds kind of weird, but it's mostly it's fairly effective, but it has a few odd side effects. And one of them is that you can't get into this situation because if you look at the comparator method, this comparator method really is comparator object because the comparable thing is erased, the parameter. This one here would also be comparator object, and you can't have two methods with the exact same signature. So it is impossible to implement comparable of a subclass here, or of a comparable of some subclass. So that's a weird oddity that we just have to live with. And that means that one has to come up with some other way of defining such a method to be universally useful. And the way that's done is to say, okay, we're going to specify more precisely what this E is. It doesn't actually have to be the same E. It could be any type that is a supertype of E. So, because over here, what are we feeding in? We're feeding in something of type E, but if comparator is willing to accept some supertype, we're okay. And so that means that the signature of Max is public static E extends comparable of question mark super E. So that is where wildcards have gotten a bad rap, because everyone who sees this says, what the heck, right? And it's not that hard to decipher them with some expertise, but at first, it's not what the blue-collar programmer would expect. Nevertheless, they do exist, so I'll just go and show you a couple of declarations in the standard library. little bigger. So if you look at the collections class, has a whole bunch of useful utility methods. And so here you see one, binary search. Takes a list of question mark extends comparable question mark super T to find a key of type T. So we're finding a key of type T in a list, and that means that the list must contain something, okay, that is comparable with supertypes of T. I would have to write this down and see exactly why this is the right type. It's not totally intuitive. Now, obviously, you have looked at this Java doc before, and you've just learned to ignore this kind of stuff. So it's not fatal, but it is a little bit weird. Here you see maps, collection of question mark extends T, and the comparator has a supertype. So when you read these things, you've kind of learned to ignore them and assume that people do the right stuff. If you ever have to write them, and no, it's not something that you have to do a whole lot, what usually works is that you use the producer-consumer analogy. So when you want to read from an array or from a list, which say max and min want to do, right? So to find the maximum, you need to read the array values. That means that the array is a producer of values, and you use extends. On the other hand, the comparator is something you put something into the comparator, and now you say, hey, how do they compare? So the comparator is a consumer, and you use super. So that basic analogy does tend to work pretty well. All right, so that is how wildcard works. And so it is a very Java-specific kind of thing. Every time that I look at a new programming language, I'm always interested in how do they solve this particular problem, that you have these generics and you want them to vary in one way or another. All right, yeah? I'm sorry? Yeah. Yes. So E is both a supertype and a subtype of itself. All right, so I'm not going to go through a lot of these limitations of generics, except for one. No, I'm not going to do it. All right, so that's all I want to say. So let's get into the lab, and then we'll see if I can debug here anything so that at least one team can give their presentation. So where's the lab? There we go. All right, so the November 10th lab. So find a buddy. Here we have a pair class. So this time I didn't want to use employee manager because I got tired of it. And so I used instead of employees, I used the class big decimal, which has large numbers. And then as a subclass, I use a labeled decimal, which has a label. So over here you see a labeled decimal, namely pi, together with a whole bunch of digits. So clearly a labeled decimal is a big decimal, but a big decimal is not necessarily a labeled decimal. So make a new project, put these two classes in there, and then implement this copy from method in the pair class that sets a pair to another pair. So here I have an example, P1 and P2 are both pairs, and so copy from is supposed to work. And then we have a similar one with copy to. And so here the trick is, of course, to figure out how to make the wildcards so that this works when one of them is a big decimal and the other is a labeled decimal, or in general any super and subclass. And then when you have extra time, then we're going to get to comparators and comparables, and that's where you're going to get into this a more complex situation with question mark extends question mark super. So see how that goes, and then we'll talk about it in a few minutes. Do we have enough people to make up pairs? Or you can figure that out.